So we're going to use algebra here to solve this equation. We've got a cos squared and another cos. So this is like solving an equation that has an x squared and another x. You're going to have to think about using factoring. This is a quadratic equation. The first thing you're going to do is set one side equal to 0. So if I move everything over to the to the left-hand side, add 3 cos squared to both sides, subtract 1 on both sides, I make it equal to 0. And at this point, you might say, I either can factor this to try to solve this, and if I can't factor this, I'm going to need to use my quadratic formula. So the first question you're going to ask yourself is, can I factor this? Does it factor nicely or does it not factor nicely? How do I know? Probably the best way to find out is to try to factor it. So if I do put brackets here and make it equal to 0, if this were factorable, can you see that this would have to be a 3 cos x and a cos x? That's the only way I could multiply my first terms to get 3 cos squared. And if I look at my last term, which is a 1, the only way that I can multiply to get 1 is 1 and 1. So we have, if this is factorable, there was actually no choice involved whatsoever. This is the only possibility. Now, we have to check whether the outside here and the inside, which I already marked, do they make plus 1? No. Doesn't matter what signs I put in here, plus or minus in between, this never works. So at this point, we can't factor. Our only option is to use the quadratic formula. Again, the quadratic formula on your formula sheet says this. For ax squared plus bx plus c equals 0, we don't have x. What do we have instead of x? We have cos x. So when we go to write out, this is very important for notation, when we go to write out our solution, we start with cos of x is equal to negative b, so a negative 1 plus or minus square root b squared, which would be 1 squared minus 4, a is 3, c is negative 1 over 2 times a. And if I simplify this, I get negative 1 plus or minus 1 minus 12 will be positive 13 over 2. So then I go to my calculator. I want to find out what these values are. Yes? Oh yes, the a value is 3. You're right. Thank you for seeing that. Would have changed everything. There. Thank you. Okay, so we get negative 1 plus or minus the square root of 13 over 6. We go to our calculator. If you have your fraction button, this is a great place to use your fraction button so that you can write negative 1. I'll do the positive 1 first. Negative 1 plus square root of 13 over 6. And my one answer for cos is cos x equals 0.434 dot, dot, dot. If I had that one, I can find cos inverse of that answer to find my reference angle, 1.12. So my reference angle for this one, are we dealing in radians? Yes, we're dealing in radians. So 1.12. I'm going to solve this one completely. If cos of x is 0.43, cos is positive. That means it's in quadrant 1 and it's in quadrant 4. So my answer in quadrant 1 will be exactly the same as my reference angle. I just did a quick check, and it said give your answers to the nearest hundredth, so I have that correct. In quadrant 4, I would do 2 pi minus my reference angle, 5.16. These are answers from 0 to 2 pi. I haven't solved if it was the minus sign. Again, the newer calculators are really nice because you can use your arrow keys to go back up to something you've typed before. If you have an older calculator that doesn't let you do that, you can also get something you typed before by pushing second enter. It'll always go up to what you typed right before. If you want to go to the one before that, push second enter again. And then second enter again until you get the one that you had typed before that you would like to use. I can now go into this equation and change that plus sign to a subtract sign and get the other side of our equation. Cos x could have been negative 0.767. And I'll put dot, dot, dot there to say I'm not rounding this. I'm keeping all of my decimal places. Now careful here, we want to find our reference angle. So we'll do cos inverse, and I want to do the answer, but what's the problem with my answer in finding that as a reference angle? It's negative. And we always do reference angles with positives. So how do I change my answer that's a negative answer to a positive answer? I could multiply by a negative 1. Does that make sense? And now I'm doing cos inverse of the positive value, and I find my reference angle is 0.6957. Again, I'm not rounding that. We only round when we get to our final answer. So from 0 to 2 pi, if that's my reference angle, I'm going to store that as x so that I can use that reference angle over and over again. Where is cos negative? Cos is negative in quadrant 2. Quadrant 2 would be pi minus my reference angle, 2.45. And cos is also negative in quadrant 3, which would be pi plus my reference angle, 3.84. And again, these are our answers from 0 to 2 pi. Whew, that's a lot of work so far just to solve between 0 and 2 pi. Now we have to remember, go back and check, and what was the domain that they were asking for? The domain they were asking for was from negative pi to pi. So if I wanted to solve from negative pi less than or equal to x less than or equal to pi, I can think, well, what does that mean? That means from 0 to negative pi in the negative direction, 0 to pi in the positive direction. Does it make sense that 0 to negative pi is looking for all answers in quadrant 3 and quadrant 4? And 0 to pi is all answers in quadrant 1 and quadrant 2. Where's 1.12? Let's just label our quadrants above here. 1.12 was in quadrant 1. So that one is going to be fine because we're looking for positive angles. So quadrant 1 will keep 1.12. Where is 5.16? That was our answer in quadrant 4, right? So this one isn't the right answer. We would have to take our angle and think, what is coterminal with 5.16 in quadrant 4? Well, our reference angle is 1.12. Can you see in quadrant 4, your angle is going to be the same as your reference angle. So we're going to get negative 1.12 for that answer in quadrant 4. 2.45, what quadrant was 2.45 in? quadrant 2. So that answer is going to stay the same. That's going to be no problem because quadrant 2 we're fine. And 3.84 was in quadrant 3. How are we going to find out what that is coterminal with that in the negative direction? Well, if you use that same reference angle, can you see that you would be going into the second quadrant in the negative direction? And so it's going to be equal to negative 2.45. And now we've solved all of our answers. I'll put a little red line through this one because this wasn't actually one of our solutions from the domain that they were asking for. Part B said determine the general solution. Well, the general solution, you solve first between 0 and 2 pi, which we did above there. You write all 4 of those out, 1.12. Sometimes they really like it if you do it in ascending order, but it would not be wrong if you didn't. And we add 2k pi to each of them. Where k is an integer. Questions for practice, 12, 13, and 14. 14 are more of these quadratic ones, but some of them you'll be able to factor. Of course, if you don't want to factor and you always want to use the quadratic formula, you can do that as well. You'll just find out that your numbers work out nice, to nicer whole numbers than they would if it wasn't possible to factor.